and welcome to today's lesson. Our subject for today is chemistry, titled States of Matter, Elements, Compounds, and Mixtures. In today's lesson, we will be seeing the states of matter and their properties, the various kinds of elements, compounds, and mixtures. And after this lesson, you should be able to answer questions regarding this topic. First, we'll start by defining what is matter. Matter is anything that has mass and occupies space. Matter is anything that has mass and occupies space. For anything to be defined as matter, it must possess both a mass and it must occupy space. Examples of matter include air, stone, animals, plants. Other examples include house, bed, every other things. However, take note, light, that is photon or electromagnetic wave, is not matter. It does not have mass, even though it occupies space. For it to be matter, it must have both mass and occupied space together. It cannot have one value and disregard the other. Now, we go into the states of matter. The states of matter include there are three basic states of matter, which include solid, liquid, and gas. Matter can exist in three basic states: solid, liquid, and gas. There are other states, including such as plasma, time crystals, and the rest of them. However, most of them are laboratory made. This is the three basic states of matter, and we are mostly concerned about these three states of matter. Now, for their definition or for their description is given. Solid. This is a state of matter in which all its particles are packed tightly together by strong electrostatic force. That is, the particles can only vibrate to and fro about a fixed point. In this state of matter, all its particles are tightly packed together by strong electrostatic force and cannot flow, but only vibrate to and fro about a fixed point. Examples include rocks, minerals, and so on. These are examples of solid states of matter. The next state of matter is liquid state of matter. Liquid state of matter is a state of matter in which all its particles or molecules have weak forces of attraction between them. They have weak forces of attraction between them, therefore, they can flow or move slowly. They can flow and move slowly. Examples include water, liquid nitrogen, raindrops, sweat, urine, etc. and so on. There are other types and examples of liquid states of matter. However, these two will be given for now. The third state of matter is the gaseous state. The gaseous state. The gaseous state of matter is a state of matter in which all its particles have negligible force of attraction between them and they therefore move around randomly. The force of attraction between gaseous particles is negligible or non-existent, therefore they move about randomly. Examples of gaseous state of matter is oxygen, nitrogen, etc. Now, we move on to our next lesson: change of states, physical states, and chemical states. But first, let us talk about the differences in the states of matter. The differences in the states of matter, differences between solid, liquid, and gaseous states. Solid. A solid has a fixed shape. A liquid has no fixed shape. It takes the shape of its container or its holding can. Gaseous state. It also has no fixed shape. It takes the shape of its container. Solid cannot be easily compressed. Liquids can also not be easily compressed, while gaseous states can be easily compressed. Solids have a definite volume, that is, they occupy a specific volume. Liquid occupy a definite volume, while a gaseous state does not have a definite volume. Solids are very, very dense. Liquids are less dense than solid, while gaseous states or gaseous states of matter are the least dense of them all. Now we move on to our next topic. We move on to the next section of our agenda. A change, we are looking at change, either physical and chemical change, both physical and chemical change. A change occurs when an object is altered either by temperature, chemical reactions, or pressure. A change occurs when an object is altered either by temperature, chemical reaction, pressure, etc., causing its state to change. For example, when water is heated, it turns into gaseous state known as steam. So, a change is said to occur when an object is altered either by temperature, chemical reactions, pressure, etc. Now let us look at the different types of change, both physical change and chemical change, and their examples. A physical change. A physical change is a change in which no new substance is formed and it is easily reversible. In a physical change, no new substance is formed and the physical change is easily reversible. Now, the examples of physical changes are dissolution of common salt. And examples of physical changes are dissolution of common salt or NaCl in water, magnetization and demagnetization of iron or magnetic elements, separation of mixtures by distillation, evaporation, fractional distillation, and the rest of separation technique. Remember, next lesson I might teach about the separation techniques and how they are used. 4. The melting of solids is an example of physical change. The freezing of liquid is an example of liquid physical change, and the evaporation of liquid is an example of physical change. Now let us move on to chemical change. In chemical changes, these are changes that are not easily reversible and new substance is formed. These are changes that are not easily reversible and new substance is formed. That is to say, in physical change, new substance is formed, and in physical change, no new substance is formed, and in chemical change, new substance is formed. Now let us look at their examples. Examples of chemical changes are the rusting of iron. Yes, when iron reacts with water in the presence of oxygen, it is reduced to iron 3 oxide. 2. Burning of materials. When materials burn, for example wood, it turns into carbon, showing a change of state. 3. Fermentation of substance. 4. Dissolution of metals in acid. When metals are dissolved in acid, hydrogen gas is liberated and salt is formed. 5. Addition of water to quicklime, which is slaking. These are examples of chemical changes. Now we move on to elements, compounds, and mixtures. Elements. These are substances that cannot be split into two by simple chemical reactions. Elements are substances with a single atom or one atom that cannot be split into two by simple chemical reaction. Now let us look at the definition for compounds and mixtures. Compounds. These are substances that contain two or more elements that are chemically combined together. These are substances that contain two or more elements that are chemically combined together. Examples include H2O and CO2. There are other examples of compound, however, this will be our main focus for today. Now, mixtures. Mixtures. These are substances that contain two or more constituents that can be separated easily by physical methods. These are substances that contain two or more constituents that can be separated easily by physical methods. Examples include petroleum and air. Other examples are available, however, we will deal with these two for this class. Now, we move on to we move on to the properties of compounds include that it has different properties from those of its constituent element. It has different properties from those of its constituent element. For example, H2O, water, is gotten when hydrogen is burned in oxygen under extreme temperature. Now, water does not support combustion. However, oxygen supports combustion. So as you can see, the properties of elements of compounds are quite different from the properties of its constituent element. 2. It cannot be separated by physical methods. Yes, you cannot separate water into oxygen and hydrogen by physical methods. 3. It has a chemical formula. Yes, compounds have a chemical formula. For example, H2O, CO2, NH3, H2O for water, CO2 for carbon dioxide, NH3 for ammonia. 4. It is homogeneous. Yes, it is homogeneous. Now we are going to look at examples of elements, particularly the first 20 elements. Note, there are over 118 chemical elements. There are 118 chemical elements. Now we move on to the first 20 elements. Now the first 20 elements goes hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, potassium, and calcium. These are the first 20 elements, first 20 chemical elements. All right, we will round it off here. And next class, we are going to talk about valency of elements. Valency, how to calculate valency, oxidation states, and the rest of all that. If you haven't watched my video on highest common factor and lowest common multiple, please do so, as it is very, very important that you know these basics. And my video on derived quantities. If you like this topic, if you like my channel, if you like my video, please like and subscribe. Thank you and have a good day.